All right, today we're going to learn about change in arithmetic and geometric sequences. And so let's start by defining a sequence. It is a function from the whole numbers to the real numbers. This means that we are only able to plug in whole numbers into a sequence, but we can get any real number as the output. As a result, when we graph a sequence, we will have points, but we can't connect them together to form a line or a curve because we can't include those points. All right, so we'll start easy and look at a sequence right here. A sub n equals 4n minus 3, and it wants us to find a sub 1 and a sub 7. So to find a sub 1, we take that 1 is in the place of n there, so we want to replace the n here for it. So we get 4 times 1 minus 3. So a sub 1 is equal to 1. A sub n in that sequence is defined by this. So to find a sub 7, we can plug in a 7 there. So we get 4 times 7 minus 3. And so a sub 7 is equal to 25. And so you can find any term in the sequence by plugging it in for the n there. All right, in this course, we're going to study two important sequences. That's arithmetic and geometric. And so we're going to start with arithmetic sequences. And so for successive terms, it tells us it has a common difference or a constant rate of change. And so when you hear that constant rate of change or common difference, you should think about your linear functions because those also have a common difference or a constant rate of change. Now, the difference again is that we are not connecting those points. So an arithmetic sequence behaves like a linear function, except it is not continuous. Increasing arithmetic sequences increase equally each step, so the slope always stays the same. They're usually written in one of these two forms right here, where a sub 0 is equal to the initial value, d is equal to the common difference, and a sub k is the kth term of the sequence. All right, so let's look at this quick example right here. A sub n is equal to 3n plus 1. So if I wanted to graph that, I can start by making a table of values. And so my 0 term, I would plug in 0 right here, and I would get 1. My first term, I get 4. My second term, I get 7, and my third term, I get 10. And so I can go ahead and graph those by plotting those points. And 3 is kind of off the table up there. It's way up there. We would not connect these points again because we're not including any of those points. The sequence only goes with the whole numbers. So those are our points in our sequence. All right, for example 2 here, it says for each of the following, determine if the sequence could be arithmetic. If yes, identify that common difference. And so for these sequences, I would go ahead and set up a table of values and plug those points in. So I'm going to make a quick table of value with my first couple terms in the sequence. And then what I can do is check to see if there's a common difference. And so between -3 and -2, that's 1, and then that's 3, and that's 5. And so we do not have a common difference here. And so this cannot be arithmetic. All right. For my second one, again, I'm going to make a table of values so I can see my sequence. And so I get 0, 6, and 1, 4, 2, 2, and 3, 0. I'm going to check my differences here, and this is going down by 2 each time. So we do have a common difference. It is right here. And so this is arithmetic because it has that common difference. And that common difference, D, would be -2 in this case because that's our common difference. All right, here's another defined sequence. In this case, they're just giving us the terms. And so this would be my first term, my second term, third term, fourth term, and so on. So I can go ahead again and check my differences. And so that is going up by 5, 5, 5. And so this is arithmetic. And that D value would be 5 because that's the common difference. Now, when I look at my last terms here, this went down by 3 and then up by 5, down by 7 and up by 9. And so this is not arithmetic because there is not a common difference. You're looking for that common difference to check to see if it's arithmetic. All right, we're going to go deeper into these sequences and continue with the arithmetic one. It says, let A sub n be an arithmetic sequence. And here they gave us the third term. That's what this means. It's the third term is 8. And then it gives us our common difference of -3, and it wants us to find the expression for A sub n. And then use it to find A sub 12. And so this is the most common one that we're going to use here, A sub n. So I'm going to go ahead and write that here for us to use. A sub n is equal to AK plus D n minus K. All right, so we're going to use that to write the equation. So it tells us that A sub 3 is 8. And then it tells us that our common difference is -3. So we're going to set this up and we're going to say A sub n is equal to my A3 right here, which is 8, has a value of 8. My common difference of -3. And then we put in the 8 here for A sub k, so my k is going to be that third term there. And so we get n minus 3 in the parentheses. And then we would want to distribute here to simplify this. And so we get -3n plus 9. And then when we combine our like terms, we get -3n plus 17. And so there is our sequence defined in this equation. Now we would use it to find A sub 12. And so A sub 12 is equal to -3 times 12 plus 17. And so that gives us -36 plus 17. And so A sub 12 is -19. And so we just wrote the equation right here for that sequence, and then we used it to find the next one. All right, for our next one here, it says, let A sub n be an arithmetic sequence with A sub 2 equals 7 and A sub 6 equals 9. Find an expression for A sub n and use the expression to find A of 24. And so there are a couple of different ways you can do this using that same equation there, or we can find our difference first. All right, so if we use the same equation that we did before, A sub n is equal to A sub k plus D minus times n minus k, I can go ahead and plug in the 7 for A sub k and the 9 for A sub n. I don't know my common difference. And so A sub n here, we had 9, so the term was the 6, so I plug that in for n. And then for the 2 here, that was my k value, and so k will be 2. And so then I can simplify this. 9 equals 7 plus D times 4. I subtract the 7 to get it to the other side, and I get 2 is equal to 4D. And then I divide, and I get D is equal to 1/2. So that's one of our options there. We can do that in order to find our common difference. Or we could do it just like we did with the linear functions. We said arithmetic worked just like the linear functions. And so we talked a lot about rate of change, the difference in our y's over the difference in our x's. We can do the same thing here. 9 minus 7 over 6 minus 2 is equal to 2 over 4, which is 1/2. Notice that either way, you're going to get the same exact thing for that common difference. And so now that we have the common difference, we can set up our equation. And we're looking for, actually, let's go ahead and do. I could use either one of these points, whichever one you prefer, to write the equation. And so I'll go ahead and use this one here. And so 7 would be my A sub k, plus we know 1/2 times my n. We don't know that one, so that's going to stay as n, minus my k value, which was 2 here. And so we distribute to solve. And so our equation is 1/2 n plus 6. Now we're ready to use that equation, and so we can find the a sub 24. And so a that's 1/2 times 24, which is 12, plus my 6, which is 18. All right, so your first step was to get that common difference using either A, the equation, or using that average rate of change, the difference in our y's over our difference in our x's. Then using the formula to go ahead and write the equation that gives you the sequence. And so that's what we wrote here. And then we use that to find what they're asking us to. So there were several steps to go through on that one. All right, for number 5 here, it says several terms of the arithmetic sequence a sub n are shown above. Find an expression for a sub n and use the expression to find a of 17. So again, we need to find that common difference. You can start by writing the equation, so you can choose either one of these formats. Instead of giving you the points though right here, they gave you the graph. So you've got the point 0, 8, you have the point 1, 6, 2, 4, and so on. Now, with my differences in y's over the difference in x's, I can count that right off the graph here. I went down 2 and over 1, and so I can see that the difference is -2. And so that's gone down 2 over 1, gone down 2 over 1 each time. So that's my common difference. So I've got that part already here. Now I'm ready to write my equation. And so our equation is a sub n ak plus my common difference, I said that was -2 times n minus k. To finish writing this, I am going to need one of the points. Whichever point you prefer, that's the one that you can use. And so I'm going to go ahead and use this first one, 0, 8. And so I plug in 8 for my a sub k. I can go ahead and put that -2 there. And so -2 times my n minus the k value, which would have been 0. And so I'm going to simplify this equation right here. And so my a sub n is -2n plus 8. Now I'm ready to use that equation to find a of 17. And so my a of 17 is -26. All right, so our first step is always to find that common difference. You can use a couple of different strategies. I use the graph here. I showed you how to do it with the difference in your y's. I showed you how to find it with your equation. Choose which method you prefer, which one's easier per problem. Sometimes you may do it one way and other times another way. All right, hopefully you feel comfortable now with the arithmetic one, so we'll switch to geometric sequences. And so it tells us that successive terms have a common ratio or constant proportional change. That's the difference between arithmetic and geometric. Arithmetic had the common difference, geometric has the common ratio. Therefore, geometric sequences behave like exponential functions. Except they are not continuous again. So our arithmetic behaves like our linear, our geometric are going to behave like exponential ones. Increasing geometric sequences increase by a larger amount each step, so the percent increase always stays the same. And so here's the two formats that we're really going to look at on equations, where g sub 0, again, is the initial value. R is that common ratio. And j sub k is the kth term of the sequence. And so let's look at what that looks like on a graph, just so that you can start picturing it and seeing how that works. And so we're going to create our table of values so you can see what that looks like. We'll start with the 0 term. Now remember, anything to the 0 power is 1. So this would be 1 times 8, which is 8. And then 1 half to the first power is just half times 8 is 4. Half to the second power is 1/4 times 8 gives us 2. 1/2 to the third power is 1/8 times 8 will give us 1. 1/2 to the fourth power times 8 is going to give us that 1/2. And so when I graph these now, I see 0, 8 is right there. 1, 4, 2, 2, 3, 1, and 4, 1/2. Notice this does not make that linear pattern because we do not have a common difference. This jump is more than the next one, which is more than the next one, and so on. So this gives you that exponential look if we were to connect our dots. But again, with sequences, you do not connect those dots. All right. So just like we did with arithmetic, we're going to look at the geometric sequences here and determine if these are geometric, and if so, find that common ratio. So I'm going to start by making our table of values. And so I'm going to plug in and get those first couple terms. And so there is my table. If I look at this, this does not have a common ratio. There's not a common thing that's multiplying to get from one to the next. So this is not geometric. All right, for our next one here, again, I'll start by creating my table so I can get the first couple terms. And I'm going to do that with an equal distance. So I'm going to get one term after the other. And so now I look at this, and this does have a common ratio. If I multiply 2 times 2, I get 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is growing with a common ratio. So this is geometric. And it does have a common ratio, and we said that is R right there. And so our R here would be 2, because that's what I'm multiplying to get to that next value. When I look at this sequence, again, there's no common ratio there, so this would not be geometric. Now for our last one here, from 16 to -8, I halved it. So it would be a -1/2 that I got right there. And from -8 to 4, that would be a -1/2. From 4 to -2, that would be a -1/2. So I'm having this every time. So this is geometric. And our common ratio would be -1/2. So that's what you're looking for in geometric ones. And so again, we'll start just like the last one. We've got some different ways of looking at these sequences. It says, let G sub n be a geometric sequence with G sub 1 being 12 and R being 2. Find the expression. And so we look at this equation again right here. G sub n equals G sub k times R times n minus k. So that's the equation we're going to write right there. And so I'll start by writing that. Get comfortable knowing that equation, because remember, there's no formula chart in AP Pre-Cal, so you're going to want to know these. So here we go, G sub n. And so I'm going to go ahead and plug in my values so that we can find that. And I'll start with the k, one of these terms. And so I'm going to go ahead and start with this one. So I plug in 12 for my J sub k. My ratio is given to us 2, so we're lucky on that part. We just need to plug that in. And then that would be n minus 1, because that k value has to match. And so the 12 was for the first term. And so I'm going to put the 1 there. And so there is my equation. G sub n is equal to 12 times 2 to the n minus 1. Now we can use that to find G sub 4, so the fourth term. And so we would get 12 times 2 to the 4 minus 1. So this stayed, my ratio was 2. The n value was the 4, because that's what I'm looking for. Now all I have to do is multiply this out. So this would be 2 to the third power, which is 8. So we get 12 times 8, which is 96. All right, we're going to look at a graph of that as well. So they gave us a graph here. It says several terms of the geometric sequence G sub n are shown above. Find an expression for G sub n and use the expression to find G sub 10. So when we look at this, it went from 4 to 2 to 1 to 1/2. So from this graph, I can go ahead and see that my common ratio is 1/2. And so I start by writing that G sub n equation, and I pick either one of the terms. I'm going to go ahead and pick this first one. And so 4 would be that first value. That's that G sub k. My ratio is 1/2, so that's what's going to go there. And since that was the one term, then I get 1/2 to the n minus 1. And we can use that. G sub 10 is equal to 4 times 1/2 raised to the 10 minus 1. These two numbers have to match since that's my n minus. All right, and so now we're just going to calculate that. And so we get 1 over 128. All right, so just to reiterate, a geometric sequence has successive terms that have a common ratio, r. This means that each term is multiplied by the same number to generate the next term. And so our general form of the equation right here, that's the one that you want to make sure that you know as you start writing these. So we're going to talk about the geometric ones that are a little bit harder. It says find the equation for the geometric sequence with G sub 3 equal to -3 and the ratio equal 10. All right, well, this one's not quite the harder one. So that's G sub n is equal to -3. We're going to plug that in because that's the value of the third term times our rate raised to our n minus 3. The k and the j of k go together. My k is 3 and my g of k is -3. So I plugged in that -3 for g of k, and then I plugged in the 3. So that's the equation right there. Here's our next one. Let G of n be a geometric sequence with G sub 2 equal 24 and R equal to 1/2. Find an expression for G of n and then use the expression to find G of 5. And so here we go. We're going to write that. Again, we start with our model right here. So G sub n is equal to 24. That's our value there, is equal to 1/2 times n minus, that's the second term, so I'm going to subtract 2 there. There's my generic form of the equation that I would want to use, and now I want to find G sub 5. So we get 24 times 1/2 to the 5 minus 2. And so that's going to give me 1/2 to the third power, which is 1/8. And so 24 times 1/8 is 3. All right, so the examples above were relatively quick and easy because we were given one term of the sequence and the value of r. However, how can we deal with problems that give us two terms but not the value of r? So in a geometric sequence, they can use both terms to create one equation in general form. You use the larger k value term as the G sub n term. Then you solve for r using the equations created from step 1. Use the value of r found in step 2 along with either term given in the problem to write the general form of the geometric. And so that sounds complicated, but we're going to get through this and show you that it's not as bad as it looks. So let G sub n be a geometric sequence with G sub 3 equals -2 and G sub 6 equals 128. Find an expression for G sub n. Use the expression for G sub n to find G sub 11. In this case, they did not give us the r. That's what makes this different and a little bit harder. But it told us to use the bigger one, so we'll use this one right here as our G sub n. And so just let's write this one more time here so that you have it and you know that's the one that you want to keep using for this. So we're going to use this as the G sub n. So 128 is equal to, and so then we'll use this one as G sub k. And so that will be -2 times my r raised to the n. Well, the n was 6 here, so that's going to be 6. And my k was 3 here, so that's going to be minus 3. So we get 128 is equal to negative 2r to the third power. Now, this is something that we can solve for, so we can solve to get that common ratio. I divide by negative 2, and I get negative 64 is equal to r cubed. And in order to get rid of a cube, we take the cube root of each side. So I'm going to take the cube root of each one of these, and we get r is equal to negative 4. So now we have that common ratio. Now I can write my equation. So I'm going to go ahead and keep the negative 2 that I already had here. I'm going to substitute my r with what we found, which was negative 4. And then that's going to be our n minus 3, which was still the k value right there. So I still have my negative 2 and my k right there. There's the general form of my equation. Now I can use it to predict other ones. So for g sub 11, I replace that n with 11. This number is going to get really big really fast, so this is one that I would plug into my calculator. Negative 4 to the 8th power. We get 65,536, and we're going to multiply that times negative 2. And so there is our value. Now that was a little bit harder, so we'll go ahead and do a second example just to see it again. Here's the 2 points that they gave us. We said we used the further term in order to solve, so I'm going to put 1.5 for my g sub n. I'm going to put 48 for my g sub k. I'm looking for that r. I don't know what it is. 7 was the n, and 2 was the k, so I get 7 minus 2 here. And so I get 1.5 is equal to 48 times r to the 5th power. I divide by 48. And this one's a little bit different than what you guys have done. Go ahead and simplify that so we have a decimal over number. Now this is a little bit different for you guys with the r to the 5th power. So I'm going to go ahead and show you that one, how to do it on the calculator, just to make sure that you can type that into the calculator. So just like before, we had a cube here, so we took the cube root. Well, here we're going to do the 5th root. And so to do the 5th root, we go to the math button. And so the math button is right there on the calculator. And then there's the cube root. Right below it, you have one with an x. That allows you to put whatever root you want there. And so we want the 5th root. Oops. I did alpha y equals to get that numerator over denominator, and I'm going to do 1 over 32, which is what we were looking for right there. And so that is 1/2, so our r is equal to 1/2. That's that first step is getting in. I just wanted to show you the computation part of the math there. Once you have it, g sub n is equal to 48. We kept that same number that was there. We found r to be 1/2. And then n minus the 2, which is the one that went with the 48 there. So there's our generic form of the equation. And now we're looking for g sub 11. And so we get 48 times 1/2 to the 11 minus 2. At this point, you're just plugging it into the calculator because those numbers got small in this case very quickly. And so we get g sub 11 is equal to 3 over 32. So that was our introduction to the geometric and arithmetic sequences. We'll continue to work with that as we go through pre-cal, but that gives you a good start on that, on the geometric and arithmetic ones.